glasses, things are going great, and they're only getting better. I'm doing alright, getting good grades, the future's so bright. I gotta wear shades, I gotta wear shades.
Okay, welcome back, A-level students. What I want to do today is go over lenses with you guys to get you ready for your quiz coming up after this video. So let's go ahead and just jump right into it. All right, so first off, as was mentioned in the earlier video this week, the big difference between lenses and mirrors, well, a couple differences, is one, lenses work via refraction while mirrors work with reflection. And also, for lenses, there are two focal points, whereas for mirrors, there are one. Okay? That's because light can go either way through a lens, but it can only go one way through a mirror. Okay? So this is a converging lens. All right? It's a converging lens because the incident rays like to come together to converge. They refract through the lens and converge to a focal point. So they refract through to a focal point. And then there's the other type of lens. It's this one. It's a diverging lens. All right? And what this is that they diverge away from, they refract away from a focal point. So they come through, right? They come through and then go away, whereas with converging, they come through and go towards. Okay, so it kind of goes with the name, converging, diverging. Okay. Equation-wise, the nice part is because lenses and mirrors are very similar in what they do, such that the converging lens is similar to a concave mirror and a diverging lens is similar to a convex mirror. Is that all the equations that we had before, the 1 over dO plus 1 over di equals 1 over f, and the HIHO divided by negative di dO equals m equation are the same, right? Also what are the same is all the positives and negatives. So f is positive for a converging lens, where it's negative for a diverging. Di is real. If it's positive, di is virtual, it's a negative. If HI or M is upright, that's positive, and if it's negative, if HI or M is negative, that's inverted, right? So again, the nice part is that the equation stuff is all the same as we did with mirrors last week. All right, so now what I have here is 3 review problems. These are going to be similar to what you see on your quiz coming up. So what I'd suggest right now is to take a second, pause, work through these 3 questions, and then what I'm going to do is go through each one of them on a separate slide coming up. So take a second, pause, and then unpause when you're ready to go. Okay, I'm ready to go. So here we go. First one reads, a 3 centimeter tall object is located 25 centimeters from a lens. The virtual image is located at 100 centimeters from the lens. Determine the focal length of the lens, the height of the image, and describe the image. All right. One of the things with these questions and these different things is trying to keep track of all the variables, because variables can get rather complicated. I shouldn't say complicated. It kind of get wordy. All right. So my biggest suggestion is to write down all the variables. So for instance, in this one it said it's a 3 centimeter tall object, so HO is 3 centimeters, and that the object is located 25 centimeters from the lens, so DO equals 25. A virtual image is located at 100 centimeters from the lens. So notice DI is negative 100. All right? It's negative because it's virtual, and it's 100 because, well, it's 100. All right? And then they start asking for what's F, what's the height of the image, so on and so forth. All right, so now that I have this, I can look and see what information I have versus what I need. So, for instance, I have DO, I have DI, I'm looking for F, so I'm going to start with this one. 1 over DO plus 1 over di equals 1 over F. I plug stuff in. 1 over 25 plus 1 over negative 100 equals 1 over F. Where F is 33.3 centimeters. Remember at the end, you need to do 1 over whatever this number is. Right? You have to do that 1 over at the very end. That's something that's a common misstep for a lot of students. Okay. So let's see here. F is positive, so that means F is a converging lens, right? Because F is positive for converging. Now I want to know the height of the image, so I go to HI over HO equals negative DI over DO. Plug in my numbers. HI over 3 equals a negative. Now notice there's 2 negatives here. It's a negative, negative, right? Because DI was negative, we have to put that in there. Negative, negative, 100 over 25. Or that HI equals 12 and M equals 4. Okay? So what does that tell us then? All right? Well, the image, first off, is virtual, right? It said that in the problem, right? But it's also virtual because di is negative. Tells us that it's upright, right? It's upright because hi, here we go, hi is positive, as well as m is positive. And then finally, it's larger because hi is bigger than ho. That's one reason. But also that m is larger than 1. All right? So look at the next one. Next one reads, a 14 millimeter tall object is 4 millimeters from a converging lens. If the virtual image is 42 millimeters tall, how far is it from the lens? What is the focal length of the lens? And it says, now notice that the hint here says, think magnification first. All right, and this is similar to one of the ones that was on your worksheet. In fact, this is the one that was supposed to be on your worksheet, but I accidentally uploaded the wrong one, so I apologize for that. So let's work through this one, though. So information-wise, HO is 14 millimeters, DO is 4 millimeters, HI is negative 42 millimeters, and we're looking for DI and F. Now, one thing notice here is I changed up the units here, but they're all consistent. All right, so the units don't have to be one specific unit, so it doesn't have to be meters or centimeters or millimeters, but as long as they're the same, all right, then you're fine. So if they're all millimeters or all centimeters or all meters, for that matter, then you're fine. Right, so but just don't cross up units. All right, so I have HO, I have HI, I have DO, but I don't have DI or F. So I really can't start with the 1 over DO, 1 over DI, 1 over F equation. I can't start with that. But what I can do is start with magnification. So HI over HO equals negative DI over DO. All right. So I plug in my HI, all right, and it's a negative 42. Now it's negative because it said it was inverted. All right, so inverted images are negative. So negative 42 equals, or divided by 14, equals a negative di over 4. And what I get is that di equals 12 millimeters. All right, so the negatives cancel. 42 divided by 14 times 4 gives me di of 12, and an m of negative 3. All right, it's negative 3 because negative 42 divided by 14 is negative 3. Plus again, negative and inverted. All right, that should be negative. Okay. Now that I have di, I can go through and solve for f. So 1 over do plus 1 over di equals 1 over f. So 1 over 4 plus 1 over 12 equals 1 over f, or f equals 3 centimeters. And again, 3 centimeters tells me that it is a converging lens because f is positive. Okay. Describing it real quick, image is real. Right? It's a real image because di is positive. Inverted because we said it was inverted, but also because m is negative, right? And hi is negative. And then that is larger, all right? M, even though it's a negative 3, all right, this is still means it's bigger than 1 because 3 is bigger than 1. The negative just tells us upright inverted. The 3 is what we want to look at when it comes to, or the number itself is what we want to look at when it comes to the larger, smaller. Last question here. An object is 14 centimeters tall and 10.3 centimeters from a blank lens. All right. The image is virtual and 6.2 centimeters tall. What is the focal length of the lens? What type of lens is it? All right. So let's see what that information tells us. All right. So height of the object is 4.1. Right. Object is 4.1 centimeters tall. And it's 10.3 centimeters from some type of lens. So DO is 10.3. The image is virtual and 6.2 centimeters tall. All right, so virtual, 6.2. And now here's something else. Virtual images, I don't know if you noticed this or not, but virtual images are always upright. All right, so when it said it was a virtual image, not only did that tell us something about our DI or what our DI should be, and we'll talk about that in a second, but it tells us what HI should be. All right, because it's a virtual image, all right, that means HI is going to be positive. Now, that also goes for real. Real images are always inverted, all right? So if this had said the image is real in 6.2, then this would be negative 6.2. All right, so I have this information. And again, I have DO, but I don't have DI and F, so I can't start with my 1 over DO plus 1 over DI equation. So I have to go to magnification. HI over HO equals negative DI over DO. So 6.2 divided by 4.1 equals a negative DI over 10.3. And again, HI is positive because it was upright. I get DI equals a negative 15.9. All right. So going through here, 6.2 divided by 4.1 times 10.3 gives me a negative 15.9, or an m that's 1.5. All right. Go to my 1 over dou di equation. So 1 over do plus 1 over di equals 1 over f. 1 over 10.3, that's my do. 1 over negative 15.9, that's my di equals 1 over f. F comes out to be 29.2, and it's still converging. So all of these are converging lenses, right? And notice also says convex. Don't worry about that necessarily. Now let's say F had come out to be negative, right? What kind of lens would that have been? Well, if F had come out to be negative, that would have been a diverging lens, all right? So kind of keep track of that. Describing the image, it's a virtual image, because first off it said it was virtual, but di is also negative, so that's another way we can know that we did the problem right. It's upright, because virtual images are always upright, plus magnification is positive, and then it is larger, because m is bigger than 1, right? As well as our hi is bigger than our ho. Okay? All right, last little bit here. I just want to go over kind of some ray diagram stuff again. For more detailed stuff, you can go back to Tuesday's video about ray diagrams. I did a really good job there with what that is. So take a look at these 3 diagrams and try to pick out which ray in each one is not correct. So for the first one, the blue ray is not the correct one. All right. The red one is our center ray, and that goes straight through the center of the lens, so that's fine. But this one, all right, if it's pointed at the far focal length, all right, hits a focal point and then goes parallel. Just goes parallel. Right? So that's what's wrong with that one. For the second one, that would be the red one. All right. And again, it's kind of the opposite of this one. All right. The center ray is supposed to go directly through the center of the lens. Well, this one hits and goes parallel, and that's not right. But the blue one is correct, because the parallel rays for a converging lens then go through the far focal point. Last one, that would be the blue one. All right. So the red one is fine through the focal point in parallel. This one, we don't aim it at this one for this. All right. This is how we would do it if it's a diverging lens. This is not how we do it for converging. So for this one, we go through the first focal point and then parallel. Then the parallel goes through the far focal. All right. Remember, when you're dealing with lenses, you can only use each focal point once for a ray diagram. All right, let's take a look at diverging lenses. All right, so again, take a look at the 3 and decide which ray, red or blue, is not correct. For the first one, it is my blue ray. All right, so again, red goes straight through. That's fine. All right. And then for the blue one, that is not correct. All right. We'd have a parallel ray that comes in and goes away from the near focal. And if this one's pointed at the far focal, that's fine. But then when it hits the lens, it's supposed to go parallel. Right? It's supposed to go parallel. The next one, which of the diagrams is not correct? Well, that would be the red one. All right. So they're both coming in parallel. That's fine. But remember, kind of like I said back here, with a parallel one, after it hits the lens, it goes away from the focal point. So it goes away from the near focal, not through the far focal. That's a converging lens idea. Then the last one, which one of them is correct, or sorry, incorrect, and it's red, all right? The blue one is just fine. Pointed at the far focal, all right? And then when it hits the lens, it goes parallel, all right? This one, however, that's not how we do this one, all right? For this one, we have a parallel ray, and that goes away from the near focal, all right? So that's not how we do this one. All right, so that about wraps it up. I just have some diagrams here so you can kind of see some images and maybe kind of go through again, you know, if this were this, what it would be. So like right now, this is an inverted real smaller image. This is an inverted real larger image. Notice this one. This one's interesting. Converging lens gives us a virtual image. That can happen. So converging lenses most of the time give us real images, but there are 2 times when they don't. Right? One is when it's at the focal point right here. That's no image, or at infinity. And the last one here is when this image, or sorry, when this object is between the focal point and the lens, it gives me a virtual image. Okay, virtual image over here. Okay, kind of interesting. Oh, and FYI too, diverging lenses, always virtual. All right, always smaller, always upright. All right. If you got questions, let me know. Otherwise, good luck on your quiz, and I will see you around. Stay safe, everybody. Bye.